This is the example on slide 72 of our Chapter 19 PowerPoint, and the question states, ozone in the lower atmosphere is a pollutant that can form by the following reaction involving oxidation of unburned hydrocarbons. Use the standard free energies of formation to determine the delta G of reaction for this reaction at 25 degrees Celsius. So one more way we can calculate the standard Gibbs free energy change of a reaction is if we know the standard free energies of formation of our reactants and products, we can use the following equation to solve for. So very similar setup to solving for a change in enthalpy or a change in entropy. Our standard Gibbs free energy change of our reaction is equal to the sum of the free energies of formation of our products minus the sum, and I forgot to have the little sum signal, but it's in there. That's a horrible summing signal. Let's see. There we go. Signal, symbol. So the sum of the standard free energy changes of our reactants. So on the slide, I have them already listed for you, and if you're following along in the lecture slides, they're in a table, or you could find them in the appendices of your lab textbook. Not lab textbook, your just normal textbook. So for this reaction, we're going to be plugging in to this equation. So first we're going to have products, free energy. So I'm going to highlight the mole amounts here. So for CO2, it's just negative 394.4. For water, it's 2 times negative 228.6. For ozone, it's 4 times 163.2. And then we're going to subtract the reactants. For methane, it's just negative 50.5. For oxygen, it'll be 8 times 0. So if we sum up the products and the reactants, you should get negative 198.8 kilojoules. And for the reactants, it's going to be positive 50.5. And if we add those together, that's going to give you negative 148.3 kilojoules. And it's technically kilojoules per mole, but the mole is understood, so we don't write it. So there you have it. That's your final answer. Our standard Gibbs free energy of our reaction is negative 148.3 kilojoules.